Well, hello everyone. This is KP the Math G. Welcome to another day of this. We are integrating by parts. And on the last video, we did that. We did two examples like that, but we did not try what we call the tabular method here. And you may be familiar with the tabular method, and if you are, then that's great. If not, I want to show you something you can do, and especially if you have an E and an X, that will work just fine. And especially you can let U. Now remember, I always like to do this. U, and there is dV. Okay, and then in this case we're going to say sine also. So the sine is important. It's going to look like this when we start it, but we're actually normally we look at this when we start, okay? But what I'm saying is we're not going to we're using it, what we say, indirectly, if you will. And we're going to do this in a tabular way, and we don't have to actually let U be equal or dV be equal to anything so far. Just follow along with me and you'll see what I'm talking about. Let's do this. Always start with plus. We're going to go right down the row, minus, plus, and minus. Now I've had to restudy this. I've seen it done before, and I've had to kind of restudy it a little bit to see how the pattern goes. You usually want U to be whatever X is. This is X cubed, so that makes dV equal to 2X, e to the 2X right here. Alright, and that's actually dx. I know we always put dx on the end, but we're just going to leave it like that. Okay, we're just copying this here. We're just leaving off the dx on the end. Okay. Alright, now every sign is alternate. Okay, that's the way it works here on this. Alright, we're going to keep doing. The idea is take the derivative of U until you get to a derivative that's equal to 0. Alright, so if I take this derivative, I've got 2x squared. If I take this derivative again, it's going to be 4x. If I take this derivative again, that's going to be 4. Well, we need another sign here, don't we? If I take this derivative again, this will be equal to 0. Alright, so 3x cubed. I'm sorry, I have done everything totally wrong, and I knew it didn't look right. KP the Math G, how could you? Come on, now. I know if you could shout through this camera, you would be telling me, KP, put the 3 in front. There we go. Now this is 6x, isn't it? Okay. Now this is 6. And now this is 0. Alright. Oh, even KP the Math G can foul something up once in a while. Alright. Now let's keep on going until we get down all the way down to where the 0 is. Alright, integrating. If it's a 2, make it a 1/2. E to the 2x, that doesn't change. Okay, when you take in the derivative of E, or antiderivative of E, even the derivative for that matter. Alright, here we go again. Alright, so let's see. So this is 1/2. Alright, times. Now if I integrate it again, that will still be another 1/2, isn't it? Alright, e to the 2x, which I'm going to fix this up. 1/2 times a half is 1/4. Alright, 1/4. 1/4. E to the 2x. Alright, if I take it again, this is going to be 1/8. Alright. 1/2 times 1/4 is 1/8. Alright, half of going all the way to 0, 1/16. And each time it's e to the 2x. So 1/2, 1/4, 1/8, 1/16. We're even. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So here's the first term. Now watch the pattern that I give you. The first term is going to be positive. Alright, so x cubed. Skip this right here. Always skip. Skip that. Alright, group these two together. Alright, so 1/2 or x cubed times 1/2 e to the 2x. So what we have here, let's just put it down as 1/2. 1/2 x cubed e to the 2x. Alright, that's that one. Now the next term is minus. Alright, let's do that. Keep going. Alright, 3 times 1/4 is simply 3/4. Alright, so this is 3/4. So minus 3/4 over 4. Well, I made that so big. I apologize. Sometimes I hold everything up, don't I? 3/4. Okay. Now what do I have? X squared e to the 2x. X squared e to the 2x. Alright. Now let's do the next one. Alright, so we have, this time we have a plus sign. So plus, alright, 6 times 1/8 is 6/8. Well, 6/8 is equal to 3/4. So another 3/4. Alright, so another 3/4. So 3/4 x e to the 2x. Alright, see the pattern? Now the next term is a minus. So minus 6 times 1/16 is 6/16. Alright, 6/16 is 3/8. 3/8 in lowest terms. So 3/8. And so minus 3/8. Alright. E to the 2x. E to the 2x. Notice there's no x on the end now. Notice how the x's keep going down. X cubed, x squared, x, and no x at the end here. That's what you want. And then finally, plus c. Okay. Now, keep in mind that we integrated and got by the tabular. Let's go back over it again. Always start with plus, minus, plus, minus. Alright, the three categories: sine, u, dB. Okay? Plus, minus, plus, minus, plus. Never how many, you don't know how many you're going to have until you start doing this. The bigger the exponent, the further down you have to go. Okay, especially if you have an x to some power, you can do this. Okay, by the tabular method, even if it's sine or cosine. Okay, we could do something with sine or cosine, but if you had something like x cubed cosine 2x or something, alright, you could easily do the same thing. But notice how you write it out. Plus x cubed, that's what you want u to be. You want dv to be equal to e to the 2x. Of course there is a dx on the end. We know that. Alright. So just keep going until you get to 0. I do my derivatives first, 3x squared. And then, of course, I will tell you this. Well, let's just finish this. 3x squared, then 6x plus 6 plus 0. Get down to the end. Keep going all the way down. And then now, just connect. This is all multiplication. 1/2 x cubed e to the 2x. There it is. Minus sign. 3 times a 4, 3/4 x squared e to the 2x. There it is. 6 over 8, which is again 3/4, positive sign. E, well, that x now, and then e to the 2x. Minus sign. 6 times 1 over 16 is 3/8 in lowest terms, e to the 2x, and then don't forget to add plus c on the end. What I would like to show, which I don't really want to at this point, but you can take the derivative of this and you can get this back. Okay. It would help if you started off by taking out e to the 2x and then doing this by the product rule, and you could get this very quick and easy. You'll see some will cancel out and you would get back to this. Amazing, isn't it? Let's do one more. Okay. I don't like to just leave you with one single example. Why do that when you can do it again? I gave this problem yesterday. I want to show you how much shorter it's going to be. I want to integrate x e to the 2x dx. Okay. Now, one thing about it, I integrated this by hand yesterday using that form. Okay. Let's see. U dv is equal to u times v minus v du. Alright, we did that. We did that pattern yesterday. Alright, so here we go. We're going to put down sine. Get a different color. Alright, so let's put it down. Sine. Alright, u dv. Alright, again the sign. Plus, minus, plus. I don't know if we have to go much further than that because here is x right here. Now, and you can go ahead and put e to the 2x here. Right here. Okay. Now, right here, the derivative of x is just 1, and the derivative of 1 is just 0. So keep going here on this one. Alright, so here we go. 1/2 e to the 2x. This one is now 1/2 times 1/2 e to the 2x. And remember, it's 1/2 again. And we put that 1/2 on the outside. So this is actually 1/4 now, isn't it? That's what I did on the last problem. So it's just like 1/4 e to the 2x right there. Alright, and then once again, skip here, skip, and then just go, the pattern goes here, like that. Alright, so let's do that. The first one is 1/2 x e to the 2x, 1/2 x e to the 2x. Alright, I think I can do now the next one. Okay, 1 times a fourth is 1/4, so minus 1/4 e to the 2x, and that's it. Now plus c. Alright, again, plus minus plus, x, derivative of x is 1, derivative of 1 is 0. Keep going till you get to 0. The reason this may not work all the time is that sometimes you may find two of them that go together and you can never get the derivative to be 0 no matter which one you win. If you did 2x, you're not ever going to get 0. So you can't put 2x here. You have to use x in the u column, or x squared or x cubed. But if you have x of anything, x squared, x cubed, x to the fourth, you can eventually get this down to 0. Okay, and that's how that tabular works here. I want to try one more thing here, and since this is a smaller problem, I'm going to take the derivative of this one. Okay, so, well, I could just leave the plus c over here, that's fine. Plus c. And, you know, I mean, I could say that, you know, I could have something, anyway, I'm going to show you what I'm going to do here. I'm going to factor out e to the 2x. Alright, that leaves me with 1/2 x. Okay. Minus 1/4. Yep, minus 1/4. And then, of course, I could put plus c over e to the 2x, because if I multiply that back together, e to the 2x times c over e to the 2x, that will give me c back. That is not necessary to do that. This is just a constant, so we're just going to leave that c out there, just like that. C is c, okay? Don't get into that habit, okay? That is just c, all right? Now, if I take this derivative, this is a product rule, okay? So let's do that. All right, so let's take the derivative. We're going to take the derivative. Okay. The derivative is the first. This is the second. All of this is the second. The first times the derivative of the second. Derivative of 1/2 x is 1/2. Derivative of 1/4 is 0. Derivative of a constant is 0. Alright. Alright. And that's the derivative of the first times the second, plus the second times the derivative of the first. Well, the derivative of this is just times 2e to 2x. Okay. Let's see here. It may be that I may have to multiply this e to both sides here. This is just 1/2. Oh, this is 0 here. So this is 1/2 e to the 2x. Alright. Now let's see. Let's multiply 2 times 1/2 x. So 1/2 x times 2 e to the 2x. Those 2's will divide out. That's x e to the 2x. So plus x e to the 2x. Alright, x e to the 2x. Alright, and then now I have a minus 1/4 times 2 e to the 2x. Well, this is actually 2/4. e to the 2x, but 2 over 4 is 1/2. So this is equal to 1/2 e to the 2x. Alright, so plus 1/2. Oh, actually it's minus, isn't it? Minus 1/2 e to the 2x. And then of course I guess plus c if we wanted to. But before we integrated, that's going to be 0. Alright, so let's see what we get here. Alright. If we look at this, this is 1/2 e to the 2x minus 1/2 e to the 2x. That is 0. And so we're left with x e to the 2x, just like we have right up here. Okay, just like that. Okay. So the first times the derivative of the second plus the second times the derivative of the first. I multiply every term back in again, multiply everything back in again, and then I see that I get this right back. Isn't that something? And that's just kind of, you know, you can take the derivative to see if you get back what you got, to see if this is indeed correct. So the answer, the original answer was, let me erase everything then. We already found out what it was. Look right here. Alright, we took the derivative here. I'll try to be brief, okay? I'm sorry I do all this and I have to erase, but I wanted to show you that it does check out. Alright, so plus c. Alright, so plus c on the end here. I don't want to ever forget that. Alright, there it is. And remember, if we took this derivative, each one individually, we would get this back. Okay, once again, in summary, when you're doing the tabular, you want to have 3 categories: sine, plus, minus, plus, like we did last time. You want to have u, and you want to have dv. Okay, you want to ignore this part. Okay, and let's say you got something here, let's say star, right here you have something like a star squared, okay, I don't know. And then right here, let's say you got 2 star, and you got something like 2, and then 0. Well, you want to keep going one more time. Okay, so this may be 1/2 star, I don't know, there's something, 1 cubed or something, okay, like that, maybe. And you're just going to go like that, and then like that. And that's what you're going to do. You're going to skip this part right up here, and you're going to just keep going down here like that. Alright, that's pretty much what I wanted to show you here. And it's just a shortcut. You know, sometimes, especially those of you who are taking the exam coming up, you want a shortcut. You see this right here. You know it's got to be done by you're integrating by parts, so you can do the tabular method really, really quickly. Okay, you got to be careful with some of it too. Okay. But if you do it, if you practice it and practice it, you'll see that you'll get it right all the time. It works out every single time. Alright, anyway. KP the Math G signing off. Don't forget, if you haven't subscribed yet, please do so. I appreciate it if you would. If you would like to make a comment, please make a comment. And if you would like to hit that like button, you see me smiling, don't you? Okay, I love that like button. It's really, really pleasant to see that. But I'm here to help you. Whether you do that or not, I'm here to help you right here. This is what it's all about. It's not about me and what glory I can get out of it. I don't seek anybody's glory. I just want to help you do better and to be successful on that exam. And if you're just a calculus student, you can be successful on your exams as well. Okay, anyway. KP the Math G signing off. Have a great, great day.